Soil moisture can be measured using the feel and appearance method, a traditional method that takes great skill and lacks a little bit of precision. Next, we have our direct measurement, which involves soil sampling, weighing, and oven drying. While accurate, it's costly, labor-intensive, and unsuitable for daily operations. Then we have our indirect method using sensors, which can provide continuous, real-time data without repeated soil disturbance. Soil moisture sensors are the most suitable option for advanced irrigation practices and water savings on the farm. They are non-destructive, require minimal soil disturbance, enable frequent monitoring for optimal irrigation scheduling, and offer a long-term effective solution to soil moisture monitoring. Sensor selection is the first key step in effective soil moisture monitoring. Factors to consider for your farm conditions are sensor type, cost, accuracy, ease of use, and durability. Soil moisture sensors measure either volumetric water content or soil water potential and can be categorized into 5 types. Neutron sensors, also known as neutron probes, capacitance sensors, TDR or time domain reflectrometry, resistance sensors such as gypsum blocks and granular matrix sensors, and tensiometers. Neutron probes are most accurate sensors but require a license to operate and cannot be easily automated. Capacitance sensors offer fast response times, provide usable trends, and are suitable for automation. However, they are sensitive to soil salinity, temperature, and clay content, requiring precise field calibration for accuracy. TDR, or time domain reflectrometry, provide rapid responses, reliable trends, and compatibility with automation. They are less affected by soil salinity, temperature, and clay content than capacitance sensors. Resistance-type sensors, such as gypsum blocks and granular matrix sensors, provide usable trends and are easy to log data. However, they do not respond quickly and require time to equilibrate with soil moisture. They are also affected by soil salinity and may need calibration over time. Tensiometers directly measure soil water tension rather than estimating it like other sensors. They can read manually using a pressure gauge or automatically with a pressure transducer that converts the readings into electronic signals for data logging. Tensiometers are widely used and unaffected by soil salinity, but require regular maintenance, including refilling with water and purging of air bubbles. After selecting the appropriate sensor, proper installation is the next critical step. It's important to follow the manufacturer's guidelines for proper sensor installation and orientation. We should always choose representative locations that reflect distinct soil types. You can accomplish this by using the database on the Grower Irrigation Academy website to see the soil types on your farm. We should always install sensors at the appropriate depths based on the effective root zone. Additionally, we should install sensors at the bottom of the root zone to assess irrigation sufficiency and detect potential leaching. We should always try and minimize soil disturbance during installation to help the soil return to its natural state more quickly, and always ensure good soil contact and prevent preferential flow and air gaps, which can compromise our data accuracy. Depending on the farm setup, data can be collected manually, either by direct reading or handheld readers, or automatically using data loggers. Manual readings are practical for smaller operations or periodic spot checks. However, they can be time-consuming, especially for large fields or frequent monitoring. Automated systems are ideal for continuous monitoring and remote access, improving efficiency and decision-making. Software tools or spreadsheets can help calculate averages and identify outliers. When analyzing soil moisture data, focus on patterns and trends to determine optimal irrigation timing and water application rates. The goal is to ensure efficient irrigation by identifying when and how much water should be applied. Soil moisture sensors allow you to do just that.